replaces equivalent concept. As you are aware of the fact that the equivalent weight of a given substance is the amount of it which exactly react with 1 gram of hydrogen or 8 gram of oxygen or 35.5 gram of chlorine. Here you can notice that we are particular or precise when it comes to the equivalent mass. As we could see that they are actually the fractions derived out of their atomic masses. So definitely my friends, there is a connection between what I am writing as the denominator to this is nothing but the valency and the equivalent mass of a substance that I am finding out. I am trying to say that if you take a particular substance, if it is able to replace any one of the three from a given solution or a compound, we call that particular amount of that substance as the equivalent mass. Now to understand this better, we write the equivalent mass. As you can see, there is a relation between equivalent mass and atomic mass if it comes to the element. I would elaborate the equivalent mass as the ratio of molar mass and a term which is under very much use for the competitive exams known as n factor. Now let me elaborate this n factor so that we can calculate the equivalent mass of a given compound. Yeah, as I just said that n factor plays a major role in finding out the equivalent mass of a given substance. Now n factor is not a constant. For a given compound in a given reaction, it may remain constant, but on the whole it is not constant like Avogadro number. At the same time, n factor is not defined as 0. It can never be a negative value. Rather, it can be a fraction. Now, explaining this n factor briefly, I would like to categorize the compounds or elements that will come across in our preparation for stoichiometry. As we say, for the elements, the n factor is nothing but its valency. As you know, my friends, valency is nothing but the combining capacity. For example, hydrogen, the valency is 1. So for hydrogen, you will write the equivalent mass as atomic mass by 1. For oxygen, you will write it as the atomic mass by valency as 2. For aluminium, it is atomic mass upon 3. So you will see that valency is nothing but the n factor in case of the elements. That is the reason why you said that the equivalent mass of a substance exactly replaces 1 gram of hydrogen, 8 grams of oxygen, and so on. In case of chlorine, you know the valency is 1. Hence you wrote it as 35.5 divided by 1. That is the reason why this is also called as valency factor. For an element, it is defined this way. If it comes to the ions, is nothing but the charge. I am writing the definition over here. For an ion, the n factor is the charge. I am going to say if you take chloride ion, I could say that equivalent mass is atomic mass or ionic mass or formula mass of this particular unit divided by the charge. If you take the other ions such as carbonate, for which you will write it as the total molar mass or formula mass is 60 upon 2, nitrate ion is 62 upon 1, and so on. So this is how you define it for the ions. Now, when it comes to the compounds, to be precise, say the acid. I am interested in finding out the n factor of the acids. I would say the n factor of an acid is nothing but the basicity. I mean the replaceable hydrogens per mole of an acid. When I say replaceable hydrogen atom, we should mind that this hydrogen is attached to the most electronegative element such as these and occasionally chlorine also. When hydrogen is attached to the less electronegative elements such as carbon, phosphorus, silicon, it can't be replaced that easily and the bond energy is high. In all these cases, when they are dissolved in water, because of their polarizability, because of the tendency to form the hydrogen bonding with water or to form the complex with water, this hydrogen atom will detach itself from these elements and come out. So when I say replaceable hydrogen atom, I must be very sure that it is when attached with these most electronegative elements of the periodic table. Now taking some cases into consideration, you have oxalic acid, the N factor is 2, you have sulfuric acid, N factor is 2, you have orthophosphoric acid, N factor is 3. Likewise, you should check whether the hydrogen is attached with the oxygen or some other elements such as phosphorus in case of H3PO. We would write radioic as 2 because we are aware of the fact that the structure formula of this compound indicate that there are only 2 replaceable hydrogen atoms present over there. So you should see whether the hydrogen is attached to the most electronegative element or less electronegative element such as phosphorus. Then we would also encounter some complex cases such as orthoboric acid. Orthoboric acid, which indeed is not a protic acid. As you are aware of the fact that the total number of electrons present with boron are 5 and 3 it has acquired from 3 OH bonds. It has formed the covalent bonds with the OH, and the total number of electrons that are present with the boron right now are only 8. It required 2 more electrons to become the noble gas. So when it is dissolved in water, it does not ionize into the borate ion. So if anybody presumes that it does this, it is wrong. It rather tries to fill its octet by forming a dative bond with water, the process of which will split this compound into this. So if anybody asks you the N factor of orthoboric acid, its reaction with any of which, say in this reaction the equivalent mass of orthoboric acid is asked, then we would say that the N factor matters here, which is being taken as 1, because you could see, my friends, that there is only one H plus ion coming out of the solution. That H plus is not indeed coming from orthoboric acid, rather it is coming from water. Hence, N factor is 1, and this is what we call as a protic, non-proton donor acid. Hence, we can find out the equivalent mass as this. And so as the case when you take a base, it is nothing but its acidity. In this case, we say that H plus accepted by 1 mole of the base. If I know correctly, NaOH accepts 1 H plus because there is 1 OH minus. Likewise, you can keep on defining for various substances, like you have ammonia, it's a Lewis base, although its N factor should be taken as 1 because it can donate only 1 lone pair or accept only 1 H plus. If you take water, don't ever expect that water is going to donate 2 of its lone pair. As you know that when it accepts 1 proton, it has become a hydronium ion in which oxygen already suffers with the positive charge. It can't afford to afford 1 more positive charge by donating the second lone pair also. Because it has 2 lone pairs, we can't expect the complexation takes place with both the lone pairs. So, N factor of H2O, when it is acting like a base, has to be taken as 1. Right. The next category is the N factor of salts. So, when salts or the ions or molecular ions are being taken, they might participate in 2 types of reaction. One you call as non-redox. The best example for that is double displacement reaction, where there is no change in oxidation state. For example, I'll take the case of barium chloride. Its aqueous solution is being added to the aqueous solution of barium to give you the nitrate and the barium and the chloride of silver. As you know that this is non-reversible double displacement reaction, where these 2 salts have reacted with each other and exchanged their ions over here. Now, as I said, in case of the non-redox reactions, the N factor of the salts is nothing but the charge of a cation, which indeed equal to the anion, since I am considering the case of neutral salts. So when I take the total charge of the barium over here or chloride, 2 into minus 1, 1 into plus 2 happens to be the same. So in factor of barium chloride in this reaction is 2. Same is the case over here. 1 barium plus 2 charge, 1 silver plus 1 charge. And the best part of the n factor is that once if you can find out the n factor of the two compounds by inverting them, we will get the mole ratio. What I mean to say is the n factor ratio is 2:1, hence the mole ratio will become 1:2, and you will see, my friends, that the equation is easily balanced. So by using this technique, we can even balance the complex reactions which are being seen in the volumetry especially. So what you will do, you just find out the n factor of a particular compound, find out the n factor of the other. Just by inverting that, you will be getting the mole ratio. And the advantage with this concept is that suppose you know the mole ratio of two compounds A and B, and you know the n factor of A, and you are struggling in finding the n factor of B because you are not sure about the definition and all that. You just invert the mole ratio, and if you know the n factor of one substance, say A, you will also find out the n factor of the other substance B. I'll tell you the example. You take sodium bicarbonate reaction with HCl, where carbon dioxide is one of the products. In this, the equivalent mass of carbon dioxide is molar mass upon n factor, which I have taken as 1. You could see that it doesn't match with any of the definition which I have discussed so far, because carbon dioxide is not behaving any like an acid, base or whatever. It's not a salt. So what I just did is that I know that it's a balanced equation, and I know that the mole ratio is 1:1, and I also know that the n factor of HCl is 1. Hence, I took the n factor also of CO2 also as 1. So I got the answer. So any complicated question, any complicated substance for which you are not able to immediately recollect the n factor can be obtained by virtue of a simple balance and finding out the n factor of the unknown substance using the n factor of the known substance. Next, moving on to the other part, redox happens to be the important one, and as you know, redox either reduction or oxidation or both. So here in reduction, there is gain of electrons. So if there is gain of electrons, naturally the oxidation number decreases. Loss of electrons, oxidation number increases. No matter what, whether that is reducing or getting oxidized, whatever, what you have to do is simple. You guys have to just see the change in oxidation number per mole of a substance. I am particular here, per mole of a substance. Total change in oxidation number is actually the n factor. Let me write the case of MnO4 minus changing to plus 2. In acidic medium, as you are aware, that the manganese would change from plus 7 to plus 2 by virtue of acting like an oxidizing agent. It gets reduced. So you have to find out the change. It's simple, because there is only one manganese which is changing from plus 7. Now, another case, say dichromate changing to plus 3, the same process. You see the oxidation number of chromium, plus 6, changing to plus 3. How much is the change? 3 units. But we could see that 1 mole of dichromate has 2 chromiums. We should always see the subscript of a substance. We should see total how many chromium atoms are changing like this. As we know that the entire chromium atoms are changing like this. If only some are changing, it's a different story altogether. But the whole thing is changing. The whole carbon atom are changing, whole chromiums are changing, whole manganese are changing. In that case, you should see how many are really changing. Right? Plus 6 to plus 3. There are 2 such chromiums are changing the oxidation state, and the n factor is 6. So when I am asked the equivalent mass of the substances, I would just write here m by 6 and here m by 5. Yeah, now based on the knowledge you procured so far, you repeatedly watch this video if you don't understand, or contact Sanjeevni. I am there to help you. So based on the knowledge that you procured, please work out these examples. You please find out their equivalent masses in terms of the molar masses. I mean to say the equivalent mass of this substance is equal to m upon what? N factor. The n factor of this case I would write as 3. I'm giving you the answers here. Just try out on your own. I'm just saying that the answer is this. So you have to find out the equivalent mass of these substances and prove that this is the right answer. Best of luck. Keep following, keep watching Sri Sanjeevni YouTube channel for more information about the stoichiometry and other chapters. Thank you.